The PCBs that replace the HD 36106 RAM chip are back, and I built one up and tried it out in a socket and found that it didn't actually work because I'd actually made a, well, it's not really a mistake, but it's a different wiring. There's two clock signals going in and I'd swapped them over, which actually leads to the output of the RAM chip when you read from it, everything being multiplied by 2, which doesn't work very well. So I've changed the code, and this was a sort of debug version, because when this thing's put together as this Raspberry Pi Pico 0 is sitting right on top of the PCB, and there's pins for the Pico to fit into the PCB and pins for the PCB to fit into the PCB of the calculator. There's no room for getting in for signals and so on, so I made this one, which is there we go, which is with the Pico up on wires so that I can access the signals. But as it turned out, it was just a different wiring of the clock, which was a mistake, but it's just different to the prototype. And if I take this apart, you can see that it fits in there quite nicely. This has got socket headers and pins so that I can actually take the board off quite easily, and you can see that it's here. Now I've put some insulation on top of the USB-C socket because it's pretty close to the keyboard, and that's something that actually happens on the 202. They put some insulating tape on the keyboard PCB. So this is now working. There's not a lot of room in there, but it fits fairly well. There's a flying lead there which goes to the chip enable of the other HD 36106 RAM chip, which is sitting here, which holds the programs, and this footprint is for the data, the memories. So if I put this back together, let's just make sure I get that correct. I don't want that to be out of line. We can, it's not easy, nothing's ever easy. There we go. And if I make sure that all the wires are in the correct positions, you can actually click the case together. It's fine, it's the same size as it was, everything fits in there nicely. Put some batteries in. There we go. And turn it on. So you can see, got a 0 there, and I have to press AC to get everything synchronized when you turn the thing on. Otherwise, when you store into a memory, so I've stored 111 into memory 1, if I get it out, it's not correct, and this is because the clock isn't synced up for the memories. The program RAM chip doesn't have that problem. So if I turn it off and on, press AC and store the same number in memory 1, you can see it works, and from then on it's in sync, so everything's fine. Yeah, what did I do there? I did something wrong there, didn't I? Oh, I stored it in 1. Oh well. So 111 in 1, 222, oh, no, enter 2, answer 1, 1, answer 2, 2. So that's fine. If you look in the programs, ordinarily there'd be nothing there in a normal 201 because it doesn't have non-volatile memory, but this one does actually have some program codes, and that's because I load slot 0 into the RAM at startup, so you've got a way of having a non-volatile program. The moment you turn it on, the program's there. It's got some bad codes due to the bug that I had, which when you looked at the program code ended up multiplying everything by 2, so that didn't work too well. But it will, I mean, that will run and do nothing. We can store a program. Let's have a loop. So SD4, which is label 4, step 4 I think it is, or something. 1 equals 1 plus K1 colon, and then go back to 4 with a colon, which is important because it doesn't work without that. We'll have a look at memory 1. It's got 111 in it, and if we go to comp and we run for a while, and it's pretty slow, you have to run for quite a while to get any sort of counts accumulated in memory 1. Go back and have a look at what's in 146. So it's added on a few numbers to 111. So it's working, and it's all contained within the original case. And because this is controlled with memories in terms of slot loading and saving, you don't really need the USB cable. It's difficult getting the cable out of here. So the best way of doing it is to use this, which is the sort of butterfly adapter, which enables you to operate the front half of the calculator while getting access to the back half, and you can put a cable in there then. I don't think it's going to be possible to really run a cable out because of the mechanical arrangement. On the Pro 101 I managed to get a cable coming out of the mains adapter hole, but I don't think it's really going to be possible here. The butterfly connector is a much better way of doing it. And because it's going to be possible to operate the thing almost entirely from the keyboard, the only thing you can't do is use ASCII labels for the flash slots. So yeah, I think that's done. I'm going to have a look through. I might convert another one. I've got quite a few 201s and 202s. Well, I've got one 202 which is broken and quite a few 201s. Quite a few of which are in a pretty bad state, so I might convert those. This one I wanted to actually do the prototype work on one that was working, because if you've got one that isn't working, it just causes problems. So this one was working and is now updated, but essentially it's the same. It's only the RAM that's been replaced, and you could take that out and put the original RAM chips back in if you wanted to, but I think it's far more useful in this sort of setup, because you've got your non-volatile program, and could be data as well. Actually, I could load the RAMs in. I don't at the moment, but you can do whatever you like really, as you've got a Pico in there.